Imagine a compass pointing south instead of north. It's a scenario that seems straight out of a science fiction novel, but it's more plausible than you might think. It sounds like science fiction, but it's a real possibility. The Earth's magnetic poles have a history of flipping, a phenomenon that has occurred many times over millions of years. Earth's magnetic poles have flipped many times throughout its history. This process, known as geomagnetic reversal, is a natural part of our planet's dynamic system. This natural phenomenon, known as a magnetic pole flip, could happen again, potentially impacting our planet and our way of life. Scientists are constantly studying this to understand its implications. The Earth's magnetic field acts like a giant shield, protecting us from harmful solar radiation. Without it, life on Earth would be exposed to dangerous levels of radiation from the sun. This invisible force field is generated deep within our planet's core. The movement of molten iron and nickel in the Earth's outer core creates this magnetic field. But what happens when this shield weakens and its poles switch places? The consequences could be far-reaching, affecting everything from animal navigation to human technology. Scientists are working tirelessly to predict and prepare for such an event. The Earth's magnetic field is like a giant bar magnet with a north and south magnetic pole. This invisible force field is crucial for life on our planet as it shields us from harmful solar radiation and cosmic rays. These poles are not fixed and can wander, even flip entirely. Over geological timescales, the magnetic poles have reversed many times, a phenomenon known as geomagnetic reversal. This flip occurs when the magnetic field weakens, allowing the poles to migrate and eventually switch places. Such events can take thousands of years to complete and have significant effects on Earth's magnetic environment. This magnetic field is generated by the movement of molten iron in Earth's outer core. The churning motion of this liquid iron creates complex patterns of electric currents. This liquid iron acts like a giant dynamo, creating electric currents that generate the magnetic field. This process is known as the geodynamo, and it has been active for billions of years. This field extends far into space, forming a protective bubble around our planet called the magnetosphere. The magnetosphere deflects solar wind and cosmic particles, preventing them from stripping away our atmosphere and making Earth a habitable place. Earth's magnetic poles have flipped numerous times throughout history. Scientists can track these flips by studying the magnetic signatures preserved in rocks and sediments. These records reveal that flips have occurred at irregular intervals, averaging about every few 100,000 years. The last flip, known as the Brunhes-Matuyama reversal, occurred about 780,000 years ago. During this flip, the magnetic field weakened significantly before eventually switching polarity. The process likely took thousands of years to complete. Section 4. The core of the matter. The exact cause of magnetic pole flips is still a subject of scientific study. However, scientists believe it is related to the complex movements within Earth's molten outer core. The outer core is a swirling mass of liquid iron and nickel. As this molten metal flows and convects, it generates electric currents that produce the magnetic field. Fluctuations in these flows can cause the magnetic field to weaken and eventually flip. Section 5. Signs of change. Scientists are constantly monitoring Earth's magnetic field for any signs of a potential flip. One area of particular interest is the South Atlantic Anomaly, a region where the magnetic field is unusually weak. This weakening in the South Atlantic has been observed for several decades and could be a sign of an impending flip. Other signs include the magnetic pole's accelerated movement in recent years. However, predicting the exact timing of a flip is currently beyond our scientific capabilities. Section 6. Ripples of a flip. While a magnetic pole flip sounds dramatic, it's important to remember that it's a slow geological process. This isn't something that happens overnight or even within a human lifetime. The gradual shift in the Earth's magnetic field is a testament to the planet's dynamic nature. The flip itself would likely take hundreds to thousands of years to complete, and life on Earth has survived numerous flips in the past. These flips are recorded in the geological history, showing that our planet has undergone this process many times without catastrophic consequences for life. However, a weakened magnetic field during a flip could have some impacts. The magnetic field acts as a shield against solar and cosmic radiation, and a weaker field could mean more exposure to these elements. It could disrupt our reliance on technology, affecting satellites, GPS systems, and power grids. These systems depend on the stability of the magnetic field, and any fluctuations could lead to malfunctions or failures. Additionally, some animals that rely on the magnetic field for navigation, such as birds and sea turtles, could experience disorientation. These creatures have evolved to use the magnetic field as a guide, and changes could disrupt their migratory patterns and behaviors, leading to broader ecological impacts.